In this lecture, we will discuss about the alkynes. That what are alkynes? So you can say alkynes are the hydrocarbons containing at least one triple bond between two carbon atoms. So previously we have discussed about the alkanes and alkenes. So you can say alkynes are having a triple bond between the minimum, I can say at least one triple bond between two carbon atoms. So you can say alkynes are unsaturated hydrocarbons which contain at least one triple bond. So this is a triple bond between two carbon atoms. So you can say they have two hydrogen atoms less than the corresponding alkenes. So we have previously discussed about the alkenes, that alkenes, the molecule, the general formula. We can say alkenes have formula CnH2n, while that of the general formula for alkynes is CnH2n minus 2. So this is the general formula for alkynes. So we can say that alkynes have two hydrogen atoms. You can say the two hydrogen atoms less than that of alkenes. Now, examples of alkynes are ethynes, propyne, butane. The simplest alkynes is, you can say, ethyne, having a molecular formula C2H2. So this is the, I can say, this is the ethyne having two carbon atoms. So if we can say this is the, you can say ethyne, so having two carbon atoms. So if we put the value of the two carbons in this formula, CnH2n minus 2, so you can say there are two carbon atoms, so instead of n, we will put 2, so C2H2 into 2 minus 2, and you can say, and C2H4 minus 2, and C2H2. So this is the example of alkynes in the form of ethyne. So you can say that ethyne is the fuel used in oxyacetylene torches. Oxyacetylene torches can reach temperature of over 3000 degree Celsius. यानी कि इथाइंस जो होते हैं जैसे कि एसिटाइलिन है, तो ये इसका टेम्परेचर जो इसका जो फ्लेम होता है इसका टेम्परेचर 3000 से ऊपर जाता है, और इसको एज ए एसिटाइलिन फ्लेम्स के तौर पर इनको टॉर्चेस में इस्तेमाल करते हैं. So I can say some of the groups member and their electrons cross and dot structure of simple alkynes are shown in table 12.3. So you can say this is the table of a molecular condensed structure and dot cross formula of the first 5 alkynes. So the first one is, you can say, ethyne or acetylene, having molecular formula C2H2 and condensed formula CH triple bond CH. So propylene or methyl acetylene, having formula C2H4 and CH triple bond C and CH3. So butylene or dimethyl acetylene, and formula C4H6. So this is the condensed formula. Pentyne C5H8. So this is the condensed formula. Hexyne, you can say C6H10 and CH triple bond C into CH2 whole thrice into CH3. So we can say now the structure formula of the first 5 alkynes. So this is the ethyne. So you can say having one triple bond, and this is the propyne having a triple bond. So you can say this is the butyne having one triple bond, and this is the pentyne having a triple bond. And this is the hexyne. We can say chain of 6 carbons having one triple bond. Now, next is the electron cross and dot formula of the first 5 alkynes. So ethyne, you can say this is the cross and dots formula of the first 5 alkynes. So you can say this is the ethyne, propyne, butyne. Or you can say that next one is the pentyne. This is the hexyne. So next is the rules for naming alkynes. The first one is select the longest continuous carbon chain containing carbon-carbon triple bond. The parent यानी पहले हम सेलेक्ट करना है कार्बन चेन लॉन्गेस्ट जो कंटिन्यूस कार्बन चेन होता है उसको सेलेक्ट करना है, लेकिन उस चेन में कार्बन ट्रिपल बॉन्ड का होना जरूरी है. Number second is the parent name is derived from the name of the identical alkanes in which the last N of alkane is replaced by Y and A. You can say in alkanes is the final 3 alphabets are A and E. So in the case of alkyne we replace the A and E by Y and E. So number the chain so as to include both carbon atoms of the triple bond. Numbering begins from the end which is nearer to the triple bond. कार्बन चेन की जो नंबरिंग होगी वो उस साइड से होगी जहां पे ट्रिपल बॉन्ड करीब होगा. तो द पोजीशन ऑफ द ट्रिपल बॉन्ड इज शोन बाय नंबरिंग द alkynes. ट्रिपल बॉन्ड की जो पोजीशन है वो उसको हम जाहिर करेंगे नंबरिंग ऑफ alkynes. नंबरिंग करेंगे कार्बन्स की जो एटम्स होते हैं उसमें. तो जिस कार्बन के ऊपर ट्रिपल बॉन्ड होगा उसको हम शो करेंगे कि ये यहाँ पर इसका है ट्रिपल बॉन्ड है. तो सो दैट द मिनिमम नंबर इज असाइंड टू द ट्रिपल बॉन्ड, यानी उस तरफ से नंबरिंग शुरू करें जहाँ पे कम से कम नंबर पे ट्रिपल बॉन्ड लगा हो. Designate the location of the triple bond by using the number of the first atom of a triple bond as a prefix. Indicate the location of the substituent by number of the carbon atoms to which they are attached. यानी कि जो सब्स्टिट्यूएंट हो जिस कार्बन के साथ अटैच होता है तो उसको हम इंडिकेट करेंगे कि इस पोजीशन पे जो सब्स्टिट्यूएंट है ये लगा हुआ है. यहाँ पर एग्जांपल दिया हुआ है. You can say the rules of for the same as discussed. So you can see this is the rules of this ethyne having one triple bond and 2 carbon atoms. So you can start the numbering in this case from any side. While in case of this structure, this is structure of propyne. यहाँ पे नंबर हम उस कार्बन से शुरू करेंगे जहाँ पे ट्रिपल बॉन्ड करीब हो. तो इस केस में यहाँ पे ये ट्रिपल बॉन्ड इस कार्बन के करीब है तो लिहाजा हम नंबरिंग को यहाँ से शुरू करेंगे कार्बन यानी फ्रॉम राइट टू लेफ्ट. सो यहाँ से हम नंबरिंग को शुरू करेंगे यानी इस साइड से शुरू करेंगे तो ये इस तरफ है इस तरफ. तो दिस इज द फर्स्ट कार्बन. यू कैन से दिस इज द ट्रिपल बॉन्ड नियर. सो वी स्टार्ट नंबरिंग फ्रॉम दिस. सो देयरफॉर इज द 1 कार्बन, इट्स 2 कार्बन, carbon number 2, and this is the carbon number 3. So we can say this is the propyne, because this chain has 3 carbons and a triple bond, so this is called propyne. So the third one example is, we can say this is the chain of 4 carbon atoms having 1 triple bond. So in this case also, the carbon, the triple bond is located near to the first carbon atom, so which is this one. So you can say we will start numbering from this side, because the triple bond is located near to this carbon, or you can say from this side. So we will start numbering from right to left on. So therefore this is a 1 carbon, this is a second, this is a third, this is a fourth. So this is the 1-butyne. And this is, you can say, the branch structure of alkyne. So we can say this is 1, 2, 3, 4, 5, 6. So this is the chain of 6 carbon atoms. The remaining carbon atoms, such as CH3, CH3, and CH3, these are substituents, groups attached to the carbon atoms. So we will start numbering from the side to which triple bond is nearest to. So in this case, we can say the carbon bond is in between the 3 carbon atoms. So this is 3 carbon atoms, so this is also the 3 carbon atoms. So the triple bond is in between this, and between carbon number 4 and 3. So in this case, we will start the numbering from that side which have maximum number of substituents. So in this case, we can say this in this side, you can say this is the 1-methyl group attached, and this is the 1-methyl group attached. So having 2 methyl groups, while in this side only 1 methyl group is attached. So we will number from that side, because maximum number of methyl groups are attached, or we can say substituents are attached. So we will number from that side. So this is the carbon number 1, this is the carbon number 2, this is the carbon number 3, this is the carbon number 4, this is the carbon number 5, this is the carbon number 6. So we can say that the name of this, we can say the name of this structure will be 2,2,5 trimethyl 3-hexane, because the methyl groups are attached to position number 2, and this is also position number 2, and you can say, and other methyl group is attached at carbon number 5. So this is, here is this one. So you can say this is 2 to 5. Is there are 3 methyl groups? So we can say this is tri-methyl. So the groups attached are methyl. So we can say these are 2 to 5 trimethyl, and the chain is containing 6 carbon atoms. So this is and having 1 triple bond, which is this one. So we can say this is the hexane. So we can say this the name of this compound will be 2,2,5 trimethyl 3-hexane. So you can say the preparation of alkynes. So alkynes is unsaturated hydrocarbons, and it can be prepared from saturated organic compounds on elimination reactions. So alkynes are prepared by the following methods. First is the dehalogenation of adjacent dihalides. So dehalogenation means removal of hydrogen from adjacent halides. So removal of halogens from adjacent halides. So you can say organic compounds in which dihalides are attached to the adjacent carbon atoms are called vicinal dihalides. So these reactions occur in 2 steps. So we can say in the first step, vicinal dihalides such as 1,2 dibromo ethane is heated with alcoholic potassium hydroxide solutions. Removal of hydrogen takes place from 1 carbon, and you can say bromine from other. It creates a double bond It produces bromo, ethane, and hydrogen bromide. So this is the preparations of you can say of alkynes. तो alkynes को हम यहाँ पर ये हमारे पास हम ये saturated compound है. You can say we have discussed that from unsaturated saturated organic compounds. Saturated, this is the saturated organic compound. You can say this is the saturated compound. You can say because it's containing all single bonds. So they are attached. You can say hydrogens and bromide ions. So you can say. So we can say this is the bromine, and this is the bromine. This is the hydrogens. So this is the saturated compounds. So you can say that the replacement of this HBr, so you can say the replacement of dehalogenations. This is the replacement of this to form, and this will be replaced to form HBr, this one. So we can say, and this single bond will be the single bond between two carbon atoms will be converted into double bond with this one. So we can say this is the dehalogenations of saturated hydrocarbons to form. This is the bromoethene. So this is the formation of we can say alkene. In the second step, this bromoethene, which having double bond, will be from this again. We can say the HBr is again removed or eliminated. So this HBr is again we can say how you can say that this HBr is removed again to form HBr, this one. So, and this double bond will be converted into triple bond here, so to form acetylene. You can say ethyne. So this is the formation of alkyne from, you can say, saturated hydrocarbons. The next one is dehalogenation of tetrahalides. Tetrahalides, you can say the compounds that contain 4 halogen atoms are the 2 adjacent carbon atoms are called you can say tetrahalides. When alkyl tetrahalides, for example, 1,1,2,2 tetra bromoethane is treated with the reactive metals like zinc dust, it eliminates or removes the bromine and forms a triple bond, producing ethyne and zinc bromide. So we can say this is the 1,1,2,2 tetra bromo methane. So in this case we can say 1,1,2,2 tetra bromoethane because of 4 bromine atoms are attached. So we can say this is tetra bromo, and these are at position number 1. Both and the next two are in position number 2. So these are 1,1,2,2 tetra bromo ethane. So the zinc, you can say it forms zinc bromide and ethyne. So this is zinc bromide and ethyne. Now physical properties of alkynes. The first 3 members of alkynes, ethynes, you can say acetylines, propines and butane are gases, others are liquids and higher side. यानी जो तीन किस्में हैं, जो टाइप्स है अल्काइंस की, जिसमें एसिटाइलिन है, प्रोपाइन है, ब्यूटाइन है, ये गैसेस है, और जो उसके बाद है वो लिक्विड्स है, जो हायर है वो सॉलिड्स है. तो अल्काइंस आर नॉट पोलर, देयरफॉर दे आर इनसॉल्युबल इन वाटर एंड सॉल्युबल इन पोलर सॉल्वेंट्स. ये अल्काइंस जो होते हैं ये नॉन पोलर सॉल्वेंट्स हैं. पानी चूंकि पोलर है तो लिहाजा ये पानी में हल नहीं होते. तो ये पोलर तो ये नॉन पोलर सॉल्वेंट्स में सॉल्युबल होते हैं. Incomplete combustion, they produces carbon dioxide and water. Produce carbon dioxide and water with the release of very huge amount of energy. With the release of a very huge amount of energy. We can say अगर इसकी कंबशन जब हो रही होती है अल्काइंस की, तो ये कार्बन डाइऑक्साइड और पानी प्रोड्यूस करते हैं, और साथ साथ जो हीट एनर्जी जो है ना, ये ह्यूज अमाउंट ऑफ एनर्जी रिलीज करता है. द मेल्टिंग एंड बॉइलिंग पॉइंट्स एंड डेंसिटी इंक्रीजेस विद इंक्रीज इन मॉलिक्यूलर मास. अल्काइंस की अगर मॉलिक्यूलर मास बढ़ाएंगे तो उनकी जो फिजिकल प्रॉपर्टीज है, मेल्टिंग पॉइंट है, बॉइलिंग पॉइंट्स है और डेंसिटी है, वो बढ़ जाती है. So next one is important reactions of alkynes, chemical properties. Alkynes are unsaturated hydrocarbons. They easily undergo addition reactions and in this way they are converted into saturated hydrocarbons. यानी कि अगर हम alkynes को रिएक्शन करा ले तो ये बहुत जल्दी saturated compounds में convert हो जाते हैं. Halogenation. Halogenation means addition of halogen such as chlorine, bromine and iodine. In the reaction, phosphorus trichloride is used as a catalyst. The addition of chlorine and bromine takes place readily when addition of iodine occurs slowly. The addition of halogens to alkynes takes place in two steps. First step. In the first step, a halogen, can say chlorine molecule, is added to the triple bond. The triple bond is converted into double bond and forms 1,2-dichloroethane. So this is the ethane. So we can say this is the halogenation of ethane. This is the halogenation. So we can say the in this case we can say these two chlorines are added to one into this carbon and second into this carbon. As a result, we can get so the other chlorine said this, one is this and the other is this. So the formation of the compound is 1,2-dichloroethane. So we can say so 1,2-dichloroethene is ethene, and this 1,2-dichloroethene is again converted on by halogenation into 1,1,2,2-tetrachloroethane. So if we add this two chlorines atoms, so they will be attached at this carbon atom and with these carbon atoms, and we will get in the presence of PCl3. So these are the chlorine atoms which are attached, and this double bond is converted into this single bond. So you can say this is the 1,1,2,2-tetrachloroethane. So this is the saturated compound formed from alkyne. Now next one is oxidations with KMnO4. Oxidation of alkyne with KMnO4. So the oxidations of ethane with ethane, potassium permanganate gives carboxylic acid and carbon dioxide, and breaking the molecule at carbon-carbon triple bond. So You can say this is the reaction of ethyne in the presence of KMNO4. So 4 oxygen are attached to here. So these are, so oxalic acid is formed and elimination of carbon dioxide. Next is the key points. So the key points, you can say we'll discuss the key points, next video.